Okay, so make a share screen. Whiteboard. Okay, so we're gonna do 2.2 today. The limit of a function. Okay, so what is the limit? Let me write down. We know what the function means. So limit. We do evaluate the function. When x approaches a given value. Okay, so let us start easy function first. So we have f over x, function notation, which is x squared, parabola. Okay, we know that. How about when x approaches to 3, okay? Then we can make a table, right? So x equal to maybe 3 here. Which number? Maybe close to, because we did the last time. If x approach to, when x equal to 3, then I said that last time, oh, maybe we can use 2.9. Oh, we can use 3.1, right? But then which number, maybe we can make a really, really close to the 3. So probably make a 3.001. You can make that, or more close, or 3.00000000000. Stop me. 0.0000001, like that, right? That's more close. How about 3.05, right? How about 3. Which one? 2.5. Bigger. How about here? 2.9999. Okay. How about here? 2.95. How about 2.9? Okay. Now, can you please plug in number and then give it to me? How about 2.9?
8.41.
8.41. How about 2.95?
8.7025.
8.7025. And 2.9999.
That would be 8.9994, and then you have 0001.
Thank you. And let's see. Let's make a 3 empty right now. How about 3.001?
It's 9.006001.
How about 3.05?
It's 9.3025.
Thank you. How about 3.25?
10.001. 56.25.
Okay, now when x approaches to 3, okay, we're going this way. So we said that this is from left. We're going this way. Let me use a different color. This is from right. Okay. Then how can we say when x approaches to 3, the function, the value? From left, from the right. What number should be there?
It's approaching 9.
9, good, right? See that? So this, sorry. Screw up, hold on. This is like that. Okay, so this is approach to 9, right? So there is a limiters. Look, I'm gonna write down this way. Limit, okay, so LIM, x approach to 3. So we read this way, limit, x approach to, let me write down in Word. X approach to. Okay. Then x squared, which is 3. Okay. Let us check that from left. X approach to, from left, we denote like this. Okay. So means from left. So the function x squared, it gives us the 3. Okay, how about the right? Okay, we denote from right this way. So this means from right. So the function gives also 3. Okay, since they match the number from the left 3, I'm sorry, it's 9. Why you no one said anything? It's 9. Oh my goodness, it's 9, right? Okay,
So those the plus and the minus tells you what direction it's coming from?
that's correct.
Okay.
Okay. So this is 9. Okay. So from left, it's 9. From right, it's 9. They matched. They agreed together, right? So in this case, look, we don't have any plus minus notation there, right? So since they match, they agree the number for the function of limit. So we just conclude the limit exists, and when x approaches to 3, the limit of x squared, which is equal to 9. All right.
So Professor, you would have all these 3
Question?
answers. Yeah, you would have all these 3 answers when you're answering for the limit of this function.
No, we have just one answer.
Oh, just one.
Unless they, Yeah, unless they ask left or right.
Oh, okay. Okay.
Okay? Just one answer. Let me erase. Okay, so we're gonna looking at the table and then we're gonna answer that. So let me use the book. Share screen. The book here. Okay, I'm using Canvas and then there is a textbook, right? So I click that. This is 2.2. Okay, so can you see this one? It's too tiny. Let me see. Make a little bit bigger. Okay. We're gonna looking at the table. All right. So how can we conclude when x approaches to 0, what is the limit of this function? How can you say that?
1.
It's 1. Good. All right. Let us do more. How about this one? So this is the graph of sin x over x, okay? So if we come from left, we approach it to 0 from the left, okay? Then the function value, so y value, which is approach to 1, it does not have to exact. Can you see that there's a hole? Okay, and if we approach it to when x equal to 0, then also the y value, the function value is 1 as well. Approach to, okay, so it's 1. How about this one? Can you please take a look?
It looks like 0.25 is what it's getting close to.
Yeah, excellent. It's getting to 0.25. So let me write down here. So 0.25. All right. So let's take a look at the graph. So from left, the function value is 0.25, approach to 0.25, right? And from the right, when x approach to 4, right? Okay. Also, the function approach to 0.25. So there is a hole that not exact number, 0.25. Okay. How about this one? Now, this time we're going to take a look the graph. I need a little bit smaller so we can see everything. Okay, so we want to know when x approach when x approach to -1, what's the limit of g of x? So -1 is here, right? So when approach to -1 from the left, what do you get?
I guess I'm not sure what that dot means, if it's telling us that it's 3 or 4.
Okay, this is a 3, this is a 4.
So is it 4 or is it 3? Because there's a gap with 3, but there's a dot at 4.
Okay, so I am standing here. Okay, I'm going this way. Okay, then my graph is here, right? So I'm following my graph. That is g of x, isn't it? Until -1. You guys understand? My g of x, my graph is this one. So what is the y value?
4.
So we just say g of x is equal to 3 or 4?
3. It's
Oh.
not the 4.
Oh, because it's included in it?
No, g of x is, look. G of x is this one. Can you see that?
Yeah.
Okay.
Uh-huh. Oh, okay, so it okay, I see what you mean.
Mm-hmm.
Okay, so it's 3 because we're looking as if we're going along the line of the graph. So like if we're going along the line of the graph coming from the left side, like we're getting closer and closer to 3, even if it doesn't touch, right?
That's correct.
Along the line of the graph from the right, it's the same.
Mhm.
It's approaching 3. So that's why, that's the why, that's the answer, right?
That's correct. So I'm standing here, I'm approaching to x equal to -1, right? So my graph is g of x is there, okay? Okay. So I'm wearing high heel and they go there when x equal to -1. All right. So the y value, g of x, is the graph. It's not the dot there, right? Okay. So it does not have to be include the number. So we see that earlier from the 2 examples, right? Okay. So it's a 3. So,
What example is this? Because I just want to write it in my notes. Okay.
what example we had?
Yeah.
We had earlier the limit x approach to 0, sine x over x equal to 1, right? And I don't remember, I think approach 4, x squared. Let me see. We have -2, it's -4, okay? Both of them has a whole, right? Because when x equal to 0, this is undefined, right? When x approach to 4, this is also undefined, right? That's why they must have a whole there, okay? So does this one, there is a whole. So -1 from the left, the g of x equal to 3, right? And we do take the limit when x approach to 1 from the right, okay? then g of x also equal to 3. Since two numbers matches, agreed, right? So we can say that, oh, -1, sorry. X approach -1, g of x equal to 3, we conclude. All right? It's okay? Yes or no?
Makes sense to me.
Okay, good. How about maybe one more, then come back to whiteboard. Okay. Okay, let's see. This one. So x approach to 0, then limit of sine of 1 over x. Take a look, this one. What can you say that?
Does it not exist?
Good, does not exist, okay? Look, we want to know about when x approach to when x approach to 0, right? The number must be like gradually it's approach to some number, right? Like earlier, 0.25, earlier, like 1, right? But this one, look, 0.54, 0.50. Okay, next one is a 0.49 and so on, right? Then we might think, right? But look, but then all of a sudden there is negative, and then 0.30 and negative. What's the number we approach, right? Does not make sense, isn't it? So this does not exist because number is not nicely approached to a number, right? Okay, let's take a look the graph. So graph, look, it's like that. So I'm standing here and I am going to approach it to 0. When x equal to 0, okay? Looking at this one. Back and forth, right? And I'm standing here and I'm walking toward to the x equal to 0, right? Same as, okay. So we called, this is accelerating. Let me write down the, oh, there we go. Here, so accelerating, can you see that? Between -1 to 1. So we read y value, right? When x approach to 0. So we said that does not exist, all right? So DNE. Okay. All right. Let us go back to whiteboard. Clear. Then stop share. Then share screen. Okay, let's go. Here we have two important limits. Theorem 2.1 said that. Two important limits. Let A be a real number and C be a constant. Okay, the first one, limit x approaches to A, then x equal to A. Okay, second one, they say the limit x approaches to A, then constant gives the constancy. All right, so this means, okay, pick a number.
7.
Oh, my favorite one. X. Look, we know how X graph, right? Like that, right? Okay. When X approaches to 7, from the left, from the right, okay, what is the function value? Otherwise, Y value. Once again, I'm standing here, go to the left, from the left, approach to 7. What's the Y value there?
Half of 7.
It's a 7, right? This is the identity function, right? And I'm standing here, I'm going to x equal to 7, right? And what's the Y value? The function value. So limit means we evaluated the function, right? So what do you get?
7.
7, right? So look, so we have, when x approaches to the number, we get the number, right? So it will be 7, the number. Can you see that? Okay, now, pick a number.
14.
14. Okay, pick a number.
3.
3. Okay, so how do we draw the 3? It's the 3 right there, right? Okay, y equal to 3, f over x equal to 3, right? There is the 3. Now, x approaches to 14 from the left. What do you get? We read the graph, the function graph.
It's still 3.
Yeah, it's a 3, right? from the right. What do you get? It's a 3 as well. Can you see? They have a C constant match, right? So 3, 3. Is it clear? So first
Yes.
one, the function, yeah, thank you. The first one, the function is x. That means the identity function. When x approaches to a number, the limit is the number, okay? The second one, if we have constant function, then no matter what x approaches to a number, we get the constant function. Is it clear?
Can you say the first one again? I get the constant function, the limit is always constant, but can you say the first one again where x?
Yeah, so this is an identity function, right? Identity function. So if we say x approach to a number, then we get the number back. Because identity function. Is okay?
That makes sense, thank you.
All right. Let me clear this one. Okay, one-sided limit. F of x equal to x plus 1 if x less than 2, x squared minus 4 if x greater or equal to 2. Second one. So your homework looks like this, okay? So x plus 1 is a straight line, so let us draw. It's like that, right? Then x is less than 2. This is a piecewise function, right? X is less than 2, so let's say the 2 is here. I need to erase some. How about like that? Oops. Okay. And there is no equal sign, so we do make a whole. Okay. Now, x squared minus 4, which is a parabola, open upwards, right? And y-intercept at -4. So like this, right? So let's say that this is but then x is greater or equal to 2, right? So a parabola like this. So let me start to like that, okay? Sorry, it should be like this. So like that, right? Okay, and then I'm gonna erase the black part because x is greater or equal to 2, so x is less than 2 part, I'm gonna erase, right? Okay. All right, so let's take a look from the left first. So I'm standing here. I am going to, from the left until 2, okay? Approach to 2. I'm going there. So what's the y value? Oh, let me write down. There is no level. So let's
You
see.
didn't put any numbers on the y
I know.
axis.
That is the one. This is the one. It's a little bit big for 1. Sorry about that. Because y-intercept, right? And 2, 3. The whole is 2, 3. I should not think about that. Hold on. Okay, good. That is a 3. Okay. All right. So once again, I'm standing there and approach to x equal to 2. Then
It would be
what's
3.
it's a 3, right? Good. Oops. How about I'm standing here and I'm approaching to x equal to 2.
Would be 0.
Excellent. This is 0. Okay. Look, from the left is a 3, from the right is 0. The number is not agreed, right? So we say that if they ask us 2, right? 2 means from left and from right. Then we can say that does not exist. So DNE means does not exist, right? Is it clear?
But isn't the second definition for the limit with x squared minus 4, isn't that inclusive of 2? That's greater than or equal than 2?
So second one, yes. Say one more time, second one, x squared minus 4, if x is greater or equal to 2. Yes.
So wouldn't the limit be so wouldn't y equal, I'm sorry, wouldn't the rule apply for the second one? Because it's inclusive of 2 as well? Do you know what I'm saying? It's greater than or equal to 2. So wouldn't it?
Yeah, so it's included 2, yes.
So I just don't get how it does not exist. I'm sorry.
Because the number is not matched. If it exists, must be 3, 3 or 0, 0.
So even though it's inclusive and you can see that like 2 is 0, y equals 0 when x equals 2.
That's correct, because the graph, can you see that?
Yeah.
We following the graph because what's the limit? We evaluate the function, right? That's why we following the graph, okay?
So there's a limit if you go from a certain direction, but there's not a limit in both directions?
I think yes, because they have to match. So like you can, there's a limit if you're just looking at it as coming from the right, then you're going to get to 1 point. And if you're just looking at it as coming the left, you're
I see that.
But
Yeah,
there's 2 different points.
See what you said. Yes.
I think.
So-
I hope this is helpful.
So just the one side. Yes.
Oh, because you're infinitely approaching it from one side, right?
One side. Just the one side. Yes.
I got you. I got you. Thank
Yeah.
you.
Sorry about that. Okay. Yeah. Good. That's why we have one side here. Yeah. So let me write down. Okay, so we have a theta 2.2, one side and two-sided limit. Okay, one side. And two-sided limit. Let me write down. Let me write down just this one. X approach to A, and the function, the limit of the function gives the L, and if and only if and only if. Okay, so this one, this means two sides is agreed, all right? Okay, so two sides is goes L, L is the number. Okay, from the left, from the right. Okay, and we can say that X approach to A, the limit of the function goes to L. Okay, is okay?
So they have to match. That makes total sense.
That's correct. Okay. Well, in this case, this is a piecewise function, all right? So we not really say that X equal to X approach to 2, right? Okay. Let us do infinite limit. Let me erase. Okay. Look. Let us do this. Evaluate the limit. From the left. Okay, they ask us only one side, okay? So 1 over x looks like that. Right? And then there's the asymptote when x equal to 0, right? Now, x approach to 0 from the left, right? I'm standing here. I'm going to when x equal to 0. So what is the function value? Looking at the graph.
Is it
Negative infinity.
The graph connected, we are looking at this graph, okay? Because I'm following the graph. Make sense? Okay.
would
So
it be
it's
negative infinity?
yes, it will be negative infinity.
And from the right would be positive infinity.
That's correct. So let's take a look. This one, second one. Okay, so your classmate said already from the right. Then we are reading the graph here, right? I'm following this graph. So goes to positive infinity, right? Okay. So at this time, they give us the question, what's the limit x approach to 0 then?
Negative infinity and infinity.
They not match, right?
So
They does not
not a
exist.
function.
Okay. Mm.
Does not exist.
Mhm. Okay. So basically, we say that the limit exists. That means the number. Okay. We don't say that limit exists for the positive infinity or negative infinity. You guys understand what I'm saying? But we just say that just positive infinity or negative infinity. Is it clear?
Yes.
Okay, good. All right. So then theorem 2.3 says that infinite limit from positive integers. Okay. Let me just write down. N is positive even. Positive even integer. Okay, we have a limit x approach to a 1 over x minus a, and then n power. This n is even power. Then goes to positive infinity. Second one. N is a positive odd integer. Then when x approaches to a, the n power gives the positive infinity as well. And oops, I missed this one, this way. This is from the right, okay? And this is from left. Okay, this one we will remember, okay? So what I do, we think about the basic function, which is 1 over x, 1 over x squared. So we just did 1 over x over there, right? So 1 over x looks like this. So we notice that where x approaches to 0, then goes to infinity or positive infinity or negative infinity, right? How about f of x equal to x squared, which is even number, right? Even integer. Then look, this one looks like that. Okay, so there is asymptote when x equal to 0, right? And y equal to 0 as well. vertical asymptote, horizontal asymptote. Then when x approach to positive when x approach to 0 from the left, what is the limit?
Infinity, positive.
Positive infinity. When x approach to 0 from the right,
The same.
same positive infinity, right? So can you realize that the bottom of 1 over x squared, n is the positive integer? That is the first one. Can you see that? Okay, and then 1 over x, which is n is the positive odd integer, that is reflected as well. Okay.
What
So
if it's, sorry, what if it's, it has to be, n has to be an even integer in order to be a positive infinity limit?
That's correct. Okay.
What if it's a negative
Remember.
or an odd?
Yeah.
What if
so
it's a
this
negative?
is they don't say the negative,
Oh, okay, okay.
only positive, right? Negative
Okay.
power we should bring up. Remember?
Okay.
So, so we cannot remember this one, the theorem. So I remember, we should remember like a basic function, which is 1 over x and 1 over x squared, right? Okay. Is it clear?
Yes, for me.
Okay, good. All right. We're gonna talk about the vertical asymptote. So let us maybe, I need 5 more minutes from, maybe 10 more minutes from now on. So please stay here. Let me make it clear.
Professor, I had a question on that. You don't have
Yes.
to bring it back. So that's just when it's 1 over something and n is in the denominator as an integer?
Yes.
Okay, so it doesn't apply to just like it being like saying that you have an exponential function and then you have n. It doesn't apply to that?
You mean the exponential function like that? This
Yeah.
exponential function?
So you have like
This is totally different. We are bless you. Bless you.
That wasn't me. I don't have to dance.
Oh. Was it cute? If that is cute, you have to dance.
It wasn't me. It wasn't me.
So we have to do this one. So we have to have this form, right? So we talk about this n. Positive or positive or even, positive even or odd, only even odd. Okay.
It only applies to that form of a.
That's correct. Only this form. Okay. And then we don't remember. We cannot remember. That's why I'm telling you only remember of this. Okay. How it looks like the graph, then we figure out, right?
Okay. All right. Yeah. Thank you.
You're welcome. Okay, so let us do vertical asymptote. Evaluate the limit. Identify any vertical asymptote. Okay, so the function. All right. Does anyone remember how to find the vertical asymptote from pre-calculus? Let me denote VA, like a vertical asymptote.
Yes.
Set the denominator
Good.
equal to 0.
Excellent. Set denominator equal to 0. Okay. And must be lowest term, right? Okay. So all the simplified already, then we set the denominator equal to 0, right? So x plus 3 equal to 0, x equal to -3, which is a vertical asymptote, right? Very good. Now we have to evaluate the limit. -3. Okay. So this one, what do you think? We have a vertical asymptote when x equal to -3. And we just learn about the power, which is even. So this one will be at 3, right? Looks like this, right? Okay. So when we approach to -3, sorry about that. Rush. Wow! I'm rushing this way. Oh! I'm rushing this way. Oh my goodness. X approach to that. All right. So this one, we have vertical asymptote when x equal to -3, right? And then this is even power. So the graph will be, looks like that, right? Okay. Then we have -3 and approach to -3 from the left. So what's the limit? What's the function value? Hurry up, we don't have time.
Positive infinity.
Infinity, positive infinity, right? Good. And
The same positive to that one too.
okay, thank you so much. Right, then how do we conclude then? Limit x approach to crazy right now. How do you say?
Infinity.
Infinity, positive infinity, all right? Okay, so let us do this one. Maybe I do just one problem, okay? Using the graph.
Was C the same as B?
We have agreed positive infinity. That's why we say the positive infinity. Make
Oh
sense?
no, because is C like a different question on
It's the
in the
same
book?
question. One is the left, one is the right, and then -3. Probably I wrote down
Oh, okay,
crazy.
yeah. That makes more sense. Thank you.
Just say, say that.
Mm-hmm.
Okay, good. Okay, let us do just this one, okay? How can I draw? Sorry, let me erase on the top. And this will be the last one for today. All right, so let me draw the graph. Ooh, like this. And then like that. They say that this is -4. And then this is -2. And this is a 6. And then this is a 3. And like this is 1. This is same spot at 1. And then, okay, they do like that. And 3 there. And they do like this. All right, so let us take a look. X approach to -4 from the left. What do you get?
0.
0. Excellent. We do X approaching -4 from the right. Okay, right.
Negative infinity.
-4. Okay. I'm up here, being here again. So I'm going to
0 as well then?
0 as well.
Okay.
Okay. Then how can we conclude?
0.
0. How about f over -4? The function.
0.
Excellent, is 0 as well. Okay. Done. So you guys understand today's lecture?
Yes.
Very good.
Miss Professor Lee,
Uh-huh.
will the video also be posted on Canvas if we want to review?
Yes.
Thank you so much.